In the interstellar space, gases tend to accumulate in clouds. The more atoms stick together, the greater the power of attraction of such a cluster is. The gravity forces within clusters are increasing, and gas ball is formed. This is unborn star. It is not ignited yet. All objects in the universe revolve around their own centers of gravity. The gas clouds also have their original spin. The unborn star revolves around its axis and moves in space around the gravitational center, which is usually located at the center of the galaxy. The movement around its own axis, however, is much faster than the rotation of the gas cloud from which it originated, because the size of the objects changed. The gas cloud circulated around its axis very slowly because its mass covered a huge piece of space in all directions. The star, which has been made of this gas cloud, takes up much less space. The gas cloud shrinks to the size of the star. The rotational spin of the star has to be relatively much faster, much more dynamic, because the size of the object changed. Our sun revolves around its axis and in the same time around the center of the galaxy. The unborn star is similar to gas planet but billions times bigger. It consists mostly of hydrogen. Over the surface, hydrogen forms atmosphere. On the surface, hydrogen has liquid form, and according to my thesis, below the surface it has the metallic form due to high pressure and temperature inside the star's body. According to my thesis, the metallic hydrogen nucleus is present inside every star, dwarf, and gas planet. It is possible that the metallic hydrogen nucleus can take more than 50% of the star volume. The idea of metallic hydrogen nucleus seems to be very important to all my future considerations. I assume that the transition of gases into liquid or metallic form is possible in proper temperature and pressure. The higher the pressure is, the easier gas transforms into liquid, especially when the temperature is low. But in the high temperature, hydrogen still can change into liquid or metallic form, if only the pressure would be high enough. There is direct link between temperature and pressure. The higher temperature is, the bigger pressure must be to make liquid or metallic hydrogen. Hydrogen on the surface of Saturn, for example, is liquid. However, the temperature is relatively high there, at least 10 Celsius degrees. This is because the pressure on the surface of Saturn is gigantic. Even bigger temperature is on the surface of our Sun, and still hydrogen is liquid there because of high pressure. The pressure inside the body of the star, dwarf gas planet, is constant on each level of depth. If so, the decisive factor for transition from liquid to metallic hydrogen and vice versa is the temperature. The deeper we go toward the core of the star made of hydrogen, the higher pressure would be there, which makes at some point the proper conditions for the metallic hydrogen nucleus appearance. In this way, in accordance to my thesis, the metallic hydrogen nucleus must appear inside every star, dwarf, and gas planet, and in my opinion, it is not very deep below the surface of the star. It means that the nucleus can take more than half of the body of the star. Our calculations how long our sun will warm us seems to be incompatible because of that. All calculations were done according to false thesis, claiming that the fusion takes place inside the core of the star, and since that, all the body of the star participate in the fusion. I claim that at least 50% of the hydrogen cannot be used as a fuel for the fusion because it remains in the nucleus and cannot participate in the fusion as long as the critical temperature will not change the metallic hydrogen into liquid and gas. This is probably 2000 Kelvin degrees. In so-called scientific models, inside the core of the star, thermonuclear fusion is located. Scientists decided to make rocky nucleuses inside gas planets because if they would agree to metallic hydrogen nucleus in gas planets, it would be incoherent to propose thermonuclear fusion in the same place in case of stars. which are very similar, because metallic hydrogen nucleus consequently should be in the core of every star as well. In this way, the basic falls. The unfortunate localization of the fusion inside star's body makes all the scientific model of the universe false. Scientists made a lot of attempts to achieve metallic form of hydrogen in laboratories, and some of them lately reached their goal. Surprisingly, the transition from liquid to metallic form of hydrogen needs rather higher temperature, not lower one, as it was supposed to be at the beginning of researches. When we froze hydrogen, it changes to liquid in very low temperature and high pressure. Consequently, it would be logical that the more pressure and the lower temperature, the bigger chance to make the metallic form of hydrogen. In contrary to these expectations, the experiments on fluid deuterium at the National Ignition Facility 2018 showed that it is possible to change hydrogen to metallic form below the temperature of 2000 Kelvin degrees. Probably this is the critical temperature of hydrogen transformation from gas or liquid to metallic form and vice versa. According to my thesis, the critical temperature is linked to supernova explosion and to black hole's origin. As we know, when the pressure increases, the temperature also increases, so the metallic hydrogen really could be nucleus of stars, dwarfs, and gas planets. The pressure and the temperature inside the core of every star probably is very high. I can say that paradoxically, the higher temperature and the higher pressure, the more likely the transformation to metallic hydrogen would be. What's interesting, the metallic form of hydrogen was described by successful experimenters as black. In the conclusion to this part of the presentation, I would say that the main factors of the thermonuclear fusion are low pressure and high temperature, millions Celsius degrees. The mass of the star is not directly related to the fusion, as scientists claim. Scientists proposed the idea of self-ignition, which could happen only if star's size would be proper. According to them, the high pressure and high temperature inside stars, possessing the proper size, would ignite the fusion in the core of stars. This is false statement because, as I said, the fusion is located in coronas of stars. There is a proof. The proof is that the coronas of stars are very hot, millions of Celsius degrees. Must be reason why, and the answer is the fusion. The model of self-ignition is not logical. If it would be true, all stars would be relatively small because they would ignite when only they would reach the proper size, according to scientists, a little bigger than Saturn. So, if they would be ignited, they will stop consume the fuel from outside. Also, it would be inexplicable why stars wouldn't blow up immediately after the self-ignition, because they all consist of hydrogen, which is the fuel of the fusion. According to my thesis, the fusion could take place even on gas planets, like Jupiter or Saturn, if only it would be triggered there, for example with H-bombs. The proper pre-existing conditions are present in upper layers of gas planets' atmosphere. According to my thesis, in nature, big mass itself would never produce temperature of millions Celsius degrees necessary to ignite the thermonuclear fusion inside stars. Stars must be big enough to make the thermonuclear fusion possible, but for other reasons. They have to possess such a strong gravity forces that it will be possible to them to attract space objects huge enough to make collisions with their bodies, and in this way make the proper temperature for the ignition, the temperature counted in millions of Celsius degrees. So high temperature is necessary to ignite the thermonuclear fusion. The temperature like this in nature could be generated only by collisions of huge space objects with stars' body. Small mass of gas planets would produce weaker gravity. Only small objects could be attracted by gravity like this. They could impact the surface of gas planets with weaker power, and this weaker impact couldn't produce the temperature of millions of Celsius degrees necessary to trigger the fusion. Gas planets survived up to now thanks to their small size and weak gravity. Because of that, there is no fusion in the upper layers of their atmosphere up to now. In the result of collisions with huge space objects, small portions of stars' bodies can escape to the outer space and form planetary systems around mother stars. Some planets could remain not ignited, similar to Saturn or Jupiter. They consist mostly of hydrogen and they are similar to the body of the mother star, our Sun, just before the ignition. The other planets could be solid, like Mercury, Venus, Earth, or Mars.